So we're going to talk about how to deal with outlying observations and, whether we can make some sense of whether this outlying um, observation is in fact influential for the regression. Typically these are, but so we'll see how to test for that. So in this example, we're going to take this data set from the Woolrich package, RDChem, which is basically on research and development expenditures. It gives you sales and it gives you profit margins of 32 chemical companies. And so here's a regression. Let's say we wanted to explain, the expenditure on research and development as a percentage of sales. So we're calling this RD in tens. Okay, maybe this is, you can take a look at this data set. And we're saying that this depends on your sales revenue. So sales is in millions of dollars, right? So if you had higher sales revenue, maybe you can devote something substantial to research and development, and also the profit margin of a company, which is measured in percentage. So let's say we get, if we include all of the observations, then we get some. This is a small data set, so I don't want to emphasize this too much, but the idea is to show you what happens. So let's say we got some kind of estimates for this, okay? And don't worry about what's significant or not at this point, but focus on, let's say the effect of sales on R&D expenditure. So look at this. This value is really, really small, okay? So this is basically telling us that while, if you do a one-sided test, this is significant, this is a value that's close to zero. But then if we start looking at outlying observations, if let's say we plot our data, right? This is, this line is the regression line that's for all of the data. If we take all of the data, and then this regression line is when we omit the outlier. And you can see that this is the outlier here, is possible outlier here, where the sales are really, really high, right? All these other firms are clustered around here. And then there are some scatters here, this one, right? But this one is like really far off, and it looks different than, it's like really far off from the rest of the cluster. So, so what we could do is we could omit this one and then rerun our regression, right? And then we get this line. This is the line of best fit. And so you see that the slope has changed considerably between, this is a flatter line, and then this is a much steeper line, which is basically showing you, if the slope is flat, right, this is a slope of 0, right? So the slope is almost flat. And then when we drop the observation, then the slope is probably positive, right? Positive and maybe a little significant. So let's take a look at what happened here. So we basically drop this firm that has sales that are really, really high relative to the rest of the companies. And when we drop that, then the coefficient increases by a lot, right? So we had a lot of zeros here before, and now we don't have that. Okay, so this definitely means that this firm was an influential observation in OLS. And you can do this, right, in R. You can basically download the data and you can regress the R&D expenditure on sales and profit margin. And you can say, and you can kind of subset the data to looking at firms that only had sales less than 30,000, right? So whatever the units are here. So this is, I believe it was measured in millions of dollars. So it's 30,000 million. That's a lot. It's a big number. But anyway, this is basically what the data set looks like. And so you can summarize it and you can see what is the coefficient here on sales. Okay, and this is like pretty much flat. And you want to probably try to understand where to stop. If you want to drop the second largest firm, you can even try to see that. So if you try to look at the plot here, you can, here we said 40,000 or 30,000 was the cutoff, right? So we said include everybody who is to the left side of the chart. So that's why we subset the data here. We subsetted the data to only include values where sales was 30,000, okay? And that's why that line changed. But we could also include everything to the left of this line, which is to say that maybe this is 15,000, right? And so you could do that as well, where you're restricting sales below 15,000 and see what happens to your estimates, okay? But yeah, the question is like, where do we stop? And there's really no concrete answer to this. The slope increases more, but reducing the variation in sales makes the estimate less precise, right? So it's sort of like this thing that we grapple with all the time. We want to exclude the outline observations that are very influential, but at the same time, we don't want to lose the variation that we have in our x's, okay? So here, if we just focused on these variables, this is probably not displaying a whole lot of variation because these are clusters, right? And these are measured here on the x-axis. So there's kind of stacked here. The x values are not changing that much. So adding those outliers actually helps us increase the variability of x. Okay, so you can read about this a little bit, but there's also something some other types of residuals that we can look at, which are called studentized residuals, and these are identical to the t-statistics on a dummy variable for that particular observation. Okay, so if you want, you can read on this a little bit from the book, but I give you I give you the code here on how to calculate that. So you will need to incorporate or download the mass package and load it to your library. And then, the regular residuals are calculated in this way, but the studentized residuals are calculated in this way, okay? You can always check based on the studentized residuals which is which location or index of the basically which is the location of the firm which has the max or the min value of a particular numeric vector. So here we're looking at numeric vectors which are regular residuals and studentized residuals, and it's giving us the same answer here, which is saying that firm number one has the maximum value from the residuals from the regression, whether we look at studentized residuals or the regular ones. So in this case, studentized residuals are not really helping us. So the conclusion is it's still difficult to decide which observations should be left out. So it's really your call, and you have to kind of lead that discussion on what's going on in your data set.